So in this video, I'm going to give you an introduction to trigonometry and the basic trig ratios. So the word trigonometry, trig literally means triangle. This metry here typically means measure, so it means like the measurement of triangles. In particular, we're going to be talking about right triangles with a right angle. I know that might not sound like it's very special, but this gets used all the time in construction, physics, computer graphics, all sorts of things, measuring earthquakes and MRIs and all sorts of things like that. So basically we're gonna be able to solve for missing angles and missing sides of this triangle besides just the Pythagorean theorem, which is all you know so far. Okay, so we've got these three words and you may recognize these from physics. We're gonna kind of explore what these mean. Sine, cosine, and tangent. Sine we typically abbreviate like this, cosine like this, and tangent like this. On their own, they don't mean anything. They have to apply to something. So like you could say the sine of 60 degrees or the cosine of x. Sometimes we even write it without the parentheses, like cosine of x. They're operations, they don't exist on their own. So just like it wouldn't make sense to be like square root. Square root doesn't make sense unless something's in there, like 25. So same thing, they're kind of parasites, they have to leech onto something. So I'm going to explain what these mean. But first, I want to go over just a little vocabulary here. Typically when we talk about, you know how usually in algebra we use x for like missing things? Oftentimes we use this symbol right here for missing angles. It's called theta, it's the Greek symbol theta, a little circle with like a line through it. Usually it's kind of squiggly. So this, you can use x if you want, but this theta is just representing a missing angle here. So if I'm looking at this triangle, I've got a right triangle and I'm looking at this angle. If I'm looking at this angle, this side right here is clearly the hypotenuse because it's across from the right angle. And then this side right here is opposite of this angle because it's across the triangle. And this side right here is adjacent to the angle. Adjacent means like right next to. See how this side is touching the angle, whereas this side is not? So if I'm looking at this angle, that's the opposite side. This is the adjacent side. Those would change if I was looking at this angle. If I was looking at this angle, then that would be the opposite side, and this would be the adjacent side. And that would still be the hypotenuse. That's going to be important here in a second, so just keep that in mind. All right. So first I just want to explore a little bit. So here are three triangles. What do we know about these triangles? So we know that they are similar. And we know that because of angle, they have the same angles, and so they're all similar triangles. And so here's the measurements of these triangles, all different sizes but the same shape. And I want you to compare some numbers here. So for example, what if I made a ratio of, like looking at this 60-degree angle, what if I made a ratio of its adjacent side to the hypotenuse? That would be 1/2. What if I looked at this 60-degree angle and made a ratio of its adjacent side to the hypotenuse? That would be 4/8. And what about this one? Square root of 3 over 2 square root of 3. Which actually simplifies to 1/2, 1/2, and 1/2. They're all the same. Let's look at another one. What about instead of adjacent over the hypotenuse, what if we compare the opposite side over the hypotenuse? So on this one, that would be square root of 3 over 2. On this one, it'd be 4 square root of 3 over 8, which simplifies to square root of 3 over 2. And on this one, it would be 3 over 2 root of 3. And if you rationalize this denominator here, that becomes 3 root of 3 over 2 times 3, which is 6, which is square root of 3 over 2. If you're not convinced on those, just put them in your calculator and you'll see that those are the same. Once again, these are all the same ratio. That actually makes sense, right? I mean, these are similar triangles, so the proportions of their sides should be the same. So what we did was, this is always going to happen. Like in a right triangle, if you have a 60-degree angle, this side compared to this side is always 1/2. This side compared to this side is always square root of 3 over 2. We could do the same thing with the 30-degree angle. It would just be called something different. So basically, what mathematicians decided is, hey, we should give this stuff a name. And so they gave names to these different combos. If you have, let me pull this up. We'll get back to that. If you have the opposite side over the hypotenuse, we call that sine. If you have the adjacent side over the hypotenuse, we call that cosine. If you have the opposite side over the adjacent side, we call that tangent. These are literally just names for ratios in a right triangle. And they will always be the same. Here you would fill in like a degree measure. So for example, instead of 60 degrees like we did on the last one, let's take a look at 40 degrees. Once again, I know these are similar triangles because of the angle property, and here are their measurements. So let's take a look at this 40-degree angle and compare, I don't know, let's just pick maybe like the opposite over the hypotenuse. So the opposite over the hypotenuse. That would be 5.4 over 8.4. On this one it would be 1.8 over 2.8. On this one it would be 9.9 over 15.4. Are those all the same? You could try them in your calculator and see. 5.4 over 8.4 is 0.642857, and so on. Same thing here, 1.8 divided by 2.8 is the same decimal, and this will also be the same decimal. So that tells me that O over H is opposite over hypotenuse. That one's the sine. So this tells me the sine of 40 degrees is this. Basically it's saying if you have a triangle, a right triangle, and one of the degrees is 40, then the ratio of the opposite side of the hypotenuse is always this. I know I'm making this sound complicated, but here's the gist. Anytime you have a right triangle and you're looking at, in this case, angle A, if I want to find the sine of angle A, I'll just compare the opposite side to the hypotenuse. If I want to find the cosine, I'll compare the adjacent side to the hypotenuse. And if I want to find the tangent, I'll compare the opposite side to the adjacent side. The order matters, by the way. And a way we often remember this is so, ka, toa. You can find all sorts of fun songs about this on YouTube. So is like sine is opposite over hypotenuse. So, and then cosine is adjacent over hypotenuse, ka, and then tangent is opposite over adjacent, toa. So you really need to memorize this so, ka, toa thing so that it will help you answer some problems. So for example, if I want to find the sine of angle B, all I'm going to do, remember sine is SOH, so, which means sine is opposite over hypotenuse. So I'll look at angle B, here's angle B, and I know that this is the opposite side, this is the adjacent side, and this is the hypotenuse because it's across from the right angle. So if I'm looking for sine, it's opposite 5 over the hypotenuse 13, and that's it. You can get a decimal if you want, but it's just 5 over 13, opposite over hypotenuse. If I want the cosine, that's ka. adjacent over hypotenuse. Adjacent over hypotenuse, which if I'm looking at angle B, that would be the adjacent side, 12, over the hypotenuse, 13. If I want the tangent of angle B, that's TOA, opposite over adjacent. So opposite over adjacent would be 5 over 12. Okay, let's switch it up here and do angle A. Note that if I'm looking at angle A, the opposite and adjacent switch. This is now the adjacent side because it touches angle A. So now this is adjacent. And now this side here is opposite because it's opposite of angle A. So now this is the adjacent side and now this is the opposite side. So if I want sine, that's so as an opposite over hypotenuse. So I'll go find opposite over hypotenuse. For angle A, this is opposite. That's still the hypotenuse, so 12 over 13. Tangent is opposite over adjacent, but for angle A, that would be 12 over 5. Okay, notice, before we get to these last two, notice that the cosine of angle B and the sine of angle A were the same. We'll talk about this more later, but that will actually always happen because, like, if I'm looking at the sine for angle A, that's opposite over hypotenuse, whereas the cosine for angle B is adjacent over hypotenuse, but the adjacent side for angle B is the same as the opposite side for angle A. And so that will always happen. All right, these last two have nothing to do with the triangle. This is saying if I had a triangle and one of the angles was 42 degrees, what would be the ratio of cosine is ka, so adjacent over hypotenuse. So what would be the ratio of this adjacent side to this hypotenuse? And it's the same for any triangle as long as the degree is 42 degrees. The good news is your calculator does this for you. You can actually type it into Google if you want. You could just type in the cosine of 42, but you do have to specify it's in degrees because there's another way to measure angles that we'll talk about later. So you can just say it in words, like type this into Google, the cosine of 42 degrees, and it will spit out the answer for you. You can also use a calculator. On the calculator, if you're using a TI-83 or TI-84, you first need to make sure you're in degree mode. If you're not in degree mode, you're going to get the answer wrong. The mode button is right next to second. I'm not sure if you can see this, but you hit mode, it's up at the top here. On the third line down, you want it to highlight degree, not radian. So have it highlight degree, and then you're in degree mode. And then you can literally just type in cosine, and the buttons for sine, cosine, and tangent are 2 rows above the numbers. They're right above the parentheses there, sine, cosine, tangent. So you just type cosine 42 and hit enter, and it gives you 0.743 ... so on. Same thing for this one, just type tangent of 113 and it gives you negative 2.35585 and so on. You can round to whatever decimal place makes sense to you. All right.